So, are there any suggestions you would give next year's class?
Okay, practice your elevator speech. The elevator speech, you do not want to be figuring that out at the fair. That didn't really happen to us, but it very well could have. Engineers want a real quick, concise answer. They want to say, what's your project about? They just want to know. So definitely take that seriously, practice it.
I guess my suggestion would be in the first term, don't, make sure you really do your research, because I know that me and Chris spent a good 30, 40 hours trying something that if we had just researched it a little bit better in the first term, we probably would have had it in 3 or 4 hours. Yeah.
You start far earlier than you think you need to, because it'll take longer than you expect.
Copy is your friend.
Always stay consistent if you're stranded for long periods of time. This could be from your classmates or from your instructors.
Keep a schedule so that everyone can meet at the same time and work on the project together.
Document the progress of your project so that you don't waste time trying to recall your previous work, and so that you can make debugging easier so while backtracking to possible source of error.
It's always good to pick your team instead of your project. That way you know who you're working with and you can work well together.
Second one is to assign tasks wisely and realistically. Just know what skills people are good at, how long it takes people to get things done, and so forth.
Order your parts early, because even if you know you have the right part, it could be that that part has a steep learning curve and you're going to need to spend some time learning how it works.
And last is communicate well with other disciplines. If your group has a mechanical engineering team in it, so if you're with mechanical engineers, they usually can start working in fall term. So if they can start working in fall term, that'd be great, because the issues are in spring term when they're gone. And then you're all alone.
Be aware of fuse bits on the microcontroller.
If the design has a mechanical portion of the project and it's an electrical engineering project, make sure that you save enough time at the end for the mechanical stuff. It's easy to underestimate how much time it will take.
And I would suggest if you're going to make a PCB board, make sure you double and triple check everything, double and triple check all the measurements that are actually part of the program as well.
And also write as much code as you can on development boards. That way, if you run into a problem, you don't have to second guess your hardware.
First, Gantt charts. It's very important to stay on track. It's very important to be realistic about what you can accomplish and be honest with yourself about where you're at. And also, probably the most important is to keep critical tasks, is to make sure that someone else or another part of the project isn't waiting on something that you have to finish, or vice versa.
A really useful help with the critical paths is to make sure at least two people are monitoring the critical paths when available.
Design ahead, budget time for testing, order parts early, order additional parts if you need. Even if you don't think you'll need them, if you can afford to, it's always nice to have. Sockets are very useful for protoboarding, breadboarding and protoboarding your designs, and testing at every step along the way is also very useful. And like I said before, ordering extra parts.
One of the first suggestions would be to start early on your project. That is very important. And don't overestimate how short things are going to take you.
My suggestion was having a lot of problems with doing things in power. Essentially, you have to keep in close touch with monitor the power team at all times, so you can get time in the lab to actually do work. You can't do it upstairs. So it's just kind of a thing of planning ahead and keeping in touch with them at all times.
Our suggestions for next year's senior design group are be really careful when you do a PCB layout. I personally laid out some we have 1, 2, 3, 4, 5, at least 5 different DC to DC converters, and I didn't check the pinout on some of them and had to mount them on the bottom side of the board. I was lucky and the pinout was symmetric, but check all of your components and super triple check your PCB layout before you order?
Also ask for help. There's a lot of people out there that know a lot more than you do. And everybody's more than willing to help you as professors, local experts that do this stuff for a living. And it really helped us to get where we are today.
I would keep a journal of problems that you come up with solutions, because maybe 2 months later you might come up with the same problem, and rather than spending a week trying to figure out the solution, you could pretty easily just look in the journal.
And keep it simple. We went a little overboard. This could power a submarine. We have so much processing power on here. There's a motherboard that we hardly even talk about. But we just wanted to be really cool. We could have kept it simple.
All right. Sure. Big suggestion is order parts with lots of documentation. Don't skimp on, buying something cheap and then end up not being able to figure out how it works. You're pretty much screwed there if you buy a new one. Sorry.
Design well before you order, because I mean, if you don't know exactly what you're going to do, you might end up ordering the wrong parts or ordering something that doesn't fully meet your standards or whatever your requirements are.
We should divide it up to instructors, just because we might be able to find like some solutions while you're talking. So I think that's one way to find solutions out of it.
Alright, so last part is establish a code structure between you and your partners, because I worked on half the code and Carl worked on half the code. And when we tried to put it first together, they look completely different. So if you had a structure of like how they had function structured and how you commented, it should go together pretty well.
If you really help, try and find a mentor that you like, or at least try and find someone that can help you. Because we had a mentor that he wasn't bad, but he didn't know anything for us, and so that made it very frustrating. And I would say definitely select your project choices very, very carefully, because we thought it wasn't really our fault either, but the project changed so dramatically that we were just like, well, this is really not.
We had a lot of trouble with the MEs would tell us what to design when we based our electronics design on it, and then a week later they tell us that they had changed it from pennies rolling on their edge to be flat with vacuum tubes, and then that changed. And so the ME design changed a lot, and we just
I forgot about vacuum tubes.
but yeah, just the communication is important.
I would just say multidisciplinary is a challenge. So if you pick that project, just know you got some other things going on, the challenges in the story, and make sure if you're working with friends, make sure you're working on tasks together. You work hard, play hard, that kind of magic.
Good. Definitely, if you do have any issues, make sure you go talk to the instructor very early. The time to tell them that you are going to have difficulty meeting one of your specs is not the day before it's due. If you realize several weeks in advance that you're going to have some sort of a problem, talk to him then. He was very willing to work with us and actually change requirements around, shift them so that we didn't have to do this requirement, but usually substitute in something else.
Learn to deal well with failure, because most of what you try will probably not work the first time. So you have to be flexible and be willing to persevere and never give up, even though it may look hopeless sometimes.
I say the big thing is start early. Start earlier than you think you really ever needed to, because you're going to run into problems and it's going to be frustrating, but the earlier you start, the better you'll do.
Make sure your specs are correct and accurate the first time, because if they change halfway through your design, it takes a lot of time to go back and redo it.
Also, something else is backups. Can't say enough about that. We had a backup chip and a backup communication protocol. We ended up using both of them. And if we would not have had it on hand, then we probably would have been about 3 weeks behind what we actually were.
Seriously consider using more standardized technology
probably staying away from the more recent development technologies because the documentation is less usually, and it's more difficult to get a hold of. And you actually discover bugs and little idiosyncrasies associated with components that are really not documented.
Simplify. The senior design is going to be very challenging, so at the very beginning, make your choices, make them wisely, and stick with what you're comfortable with and what you know.
Don't procrastinate and always assume that your programming is going to take far longer than you think.
Consider your workload, the schedule. You know, it's 2 credit class. It takes up a lot more time, depending on the project.
So along the way, we learned a lot. Some of the things we learned were it's really important to have a good background in some of the IC design courses before you actually start designing ICs. For us, it would have been really helpful to have 423 and 520, which are some of the CMOS design classes. Also, 474 if you're just wanting to design a digital integrated circuit would be important. And also, don't be afraid to talk to professors. We always put in a joke here, except we don't know anything. But in reality, like you want to be able to talk to people. Professors are usually open and have a little bit of knowledge to share.
So I guess my first recommendation for you is to pick somebody and to pick group members that you've already worked with, that you already have a relationship, perhaps even that you're friends with. Your group members are going to determine a lot of your success. They're going to have a lot of say in how well your project does and how much you enjoy working with your project.
I think a project that has a good mentor or finding a good mentor for your project is really important. We were fortunate enough to have a mentor here in our department that we could go talk to, almost any day we needed to. So that was definitely a key to our success.
Also, don't put off your design. We were kind of forced into this because we had to get our design out early to get it fabricated, but it allowed us to breathe a lot easier during winter terms. So getting the design done early will definitely get you underway. Start things twice as early as you think you need to.
I would say better deal with stress well. Once it doesn't work, don't get frustrated. Take a walk at the beach or for a lighter, whatever goes to go. Until you have control your anger, then come back to the project. And then also a specific one, just make sure triple check your PCB layout with your schematic as well as the data sheet. We had that problem, it was my fault, and caused us a tremendous amount of time troubleshooting because we thought the PCB was tight.
I would say don't try to limit yourself to the technologies you know. We played around with a new microcontroller with JTAG debugging, which is really cool. And it saved a lot of time, despite having to learn the microcontroller. And I think another piece of advice I would give is to design it well in the beginning. If you design it well, you won't have to worry about a lot of design flaws in the future.
JTAG debuggers are your friend. They are very, very useful. One of the things, read through the data sheets. There are going to be a lot of errors. Be aware of that. Follow the reference designs that they provide. And if a device you're using has a test mode, that builds right into your test plan right there. And it's very useful for troubleshooting, figuring out if your device is going bad. And if you are having an issue like we did, where we had some odd things, don't be afraid to ask the TAs or any of the other instructors or just anyone else, because they might just go, oh, okay, here's my deal. Just get an outside opinion.